Hey guys, welcome back. I just wanted to kind of do an update video talking about what I've been working on. Um, so this is a 3D model of the top part of a pencil. It's a Pentel Twist-Erase. It's a mechanical pencil with a extendo eraser, I guess. Basically, a thread in this top section here and a long eraser, so you can twist it so you end up with an eraser that's 1.5 inches long instead of the 1/4 inch long. Um, I like this because it makes it a lot easier to make mistakes, I guess, and they're just nice pencils. Um, I'll have a picture on screen, I'm sure. Um, but of course, they're all plastic, injection molded. So I wanted to try to make a metal one, aluminum, titanium, maybe even some Damascus steel at some point, because I like these pencils and I don't lose them that much. So it'd be cool to have like kind of a custom one, especially if I had like my name on it. I could even add my phone number maybe, um, so that if it's lost, it could be returned to me. So yeah, here's the 3D model of it. It ends up being a about a 4 TPI thread, and we can see it's a very unique thread form. It's no standard. So because of that, to make this part, I need to make a tap to cut the threads. So here's the 3D model of a tap I have. Um, I'll explain what I just had to do there in a minute, but here I'll just clean it up, get rid of that. Here you can see pretty basic tap design, slight taper in the front, and then just the thread pitch going around it with 3 flutes. This edge right here being a sharp 90 is not necessarily the strongest, but it's the I will just cut it with a flat end mill, so it makes it easy to make, and it leaves a good cutting face here, easy to sharpen. It's also, as you can see, the actual amount it's going to be cutting is pretty minimal because it's just this little area right here, compared to a typical tap where it has to cut a pretty deep full thread form. This one, it's really a small area it has to cut. So I'm not too worried about the strength of it, especially being about 3/8 diameter. It's a little bit under, which also adds some difficulty in making it because it's hard to hold. You don't have, it's not a standard collet size. After doing some experimentation, it looks like I can hold it in a 5C collet. Here, we'll get rid of the thread pitch so we can just look at the blank before we cut the threads in it. This diameter right here, we should be able to hold that in a 3/8 5C collet, which makes it easier to turn. Here's the cam toolpaths for this. I'll be turning this on a ST10 Haas lathe. This of course could be made on a manual machine. I believe the issue with doing that is just cutting the thread pitch. So just doing this part, just turning the diameter with this taper on the front. Obviously you can do that on a manual lathe. And then I switched to a different tool here. We just simulate it real quick. You can see I use a VNMT insert or something like that. That has a, I don't know if you call that a steep angle or a shallow tip angle, so that it can reach down this face here and do it all in one operation. I'm hoping this will make it easier to get the correct length, because the way I had this first done was that I would just face one end, turn down this 1/4 inch shank, and then take it out of the chuck and turn it around and then turn the face and then just up to this edge. I tried that and on just a piece of test aluminum and it chattered a lot. I can show a picture of that here. So I'm trying to figure out a better way to do it. I also, because of having to take it out and flip it over, getting the length correct is not particularly easy. You have to try pretty hard, and so it's just easier by doing it all in one operation here. Well, basically I don't have to put it in the chuck correctly and measure off correctly. So I'm going to be making this out of a piece of A2 scrap steel I got off eBay actually. I'm still going to run a couple of aluminum parts to make sure all my cam toolpaths work and the part works. In the end, I can measure the thread pitch, make sure it threads into the original part basically. I have this one weird issue. I don't know, maybe it's just the way you're expected to do it, but in HSM Works, I have to like go back and forth changing my history using my tree um, to get all the tool paths to work because I can't figure out how to turn just like this outer diameter without it trying to go into these threads because it only looks at like a cross section of the part, even though these threads, obviously you can't just turn this like grooves because it's a spiral, not individual flanges, but HSM Works looks at it like these are just individual grooves. So I have to go into this and drag this to, different parts of the operation like I just had it, or now I can do all the lathe toolpaths, and then I have to drag it down to do the helical swarf fourth axis passes. So here you can see those. So this is just a 3/16 end mill. We can simulate it real quick. Speed this up. So here you can see it's just spinning around. Oh god, that's not how you do that. But kind of simple it looks like, but it took me forever to figure this out. The swarf toolpath is kind of a pain, and it still does some weird stuff. It kind of has this first kind of cut. I don't know what it thinks it's doing, and I can't figure out how to prevent it from doing that. It doesn't look like it harms anything though, so whatever. And then here's the actual toolpath I want. And then you can see these grooves are about 200 thou, so a 3/16 end mill doesn't quite cut the full width, which is what I wanted, so I have two of these, one on either side. You can see that. Let's do a quick simulate. You can see both tool paths running down the middle. So one and then two. This way I get a decent finish on both sides of this, at least that's the hope. But yeah, you can see I have to protect these tool paths so they don't regenerate with the different model size. And then here I have the tool paths for the grooves. Just 2D contours with tool orientation. So just have tool orientation on, selected a face and the origin, basically. I have not proofed this toolpath on the machines or anything like that, but it looks pretty simple. Hopefully it'll work out. Spent today putting the code onto the Haas controllers. It's a Haas mini mill with a axis. It looks like it's going to work. The one issue is this clearance. This toolpath goes up till pretty much the tool ends up being a little past this edge on center line, so we need to stick it out from the collet a little ways and then use an ER16 extended tool holder to make sure we have enough clearance against the 5C indexer. I'm still looking at that. Hopefully it's going to clear, but it's pretty close. That's something I'm going to have to figure out. It might be better in the final thing to do, this turning operation, just this one, take it out, and still have a big, here, we'll go back and look at that operation with the correct model. I don't know, I'm kind of thinking it through right now, but it might be worth doing this operation, so just this one, and then taking it out of the lathe, holding onto it in the A-axis of the mill, do these two tool paths to cut the thread, then take it back out of the A-axis on the mill, and go back and then do this operation and part it off. That way I can hold on to it relatively sturdily. I don't have this 1/4 inch shank. I got a pretty decent 3/8 diameter basically holding out. That might give me the most clearance. So yeah, that might be the best way to do it. So I could split up these two and then these two later, and then do these swarfs and then the 3 contours for the flutes. This is just one of those things that I'm, the more I try to do it on the machines, the more I learn about the ways to do it and potentially better ways to do it. It's kind of an interesting project. It's kind of fun to be messing around with some more complicated tool paths. I've obviously done some basic ones, engraving stuff on my CNC router, but now being able to use industrial level CNC machines has been really cool because I'm getting to mess around with these more complicated tool paths. The one thing is that Of course, I'm sure everyone's going to ask why I didn't just use a single point threading operation instead of this fourth axis. Was it Swarf toolpath? And that's partly because I want to use the fourth axis, and partly because I don't know how well that would work, because the form tool would have to be pretty specially ground. So it will have to be ground with a lot of side clearance this way and this way, so that it doesn't bind up as the thread spirals down at this angle. This generally isn't really something you consider because you grind slight clearances in the sides of tools anyway, but with this steep of a helix on such a small diameter, it becomes a really big issue. So the cutter would have to be really specially ground, which isn't really a problem. I could do it on my surface grinder or by hand. The other issue is this is a square thread form, so it would be a pretty big cut even if I'm only going in half a thou, which is really best I could accurately feed in. I'm still cutting a 1/4 inch, or it might be closer to 200 thou width of cut, which is in a single chip is that wide, which is pretty big. Even if it is only 5 thou deep, that's still a huge amount of force, especially on this little 3/8 diameter. So I could probably have to put a tailstock in and do a lot of spring passes, and I don't think it would give the best surface finish or anything like that. So I think that this milling operation will be a lower force operation because I can change the feeds. I can go really, really slowly, and feed-wise, rotational-wise, with still having a decent chip load per tooth on a 4-flute end mill. Of course, maybe I'll be eating my words once this completely fails or crashes or whatever, but this is my hope anyway right now. So yeah, that's this part. I'll try to get some video of it. It's kind of hard to film inside the CNC machine, so much coolant going around and stuff. And I'm on I don't think the teacher would appreciate me trying to film and run a expensive machine, basically. Which, fair enough. I don't want to crash it because I'm trying to film. So I'll try to show pictures at least of the final parts and the process. Here's turning one of the aluminum prototypes on the lathe. As you can see, there's a lot of coolant everywhere. Here's the first prototype. I ended up not cutting the threads in this one because I just wanted to test out the lathe toolpaths. Here's the fourth axis cutting. Once again, another aluminum prototype before I used my expensive steel. Here's, I just finished off cutting the A2 tool steel one, just the helix part, and here's the final part coming off the mill, finished cutting the helix and the cutting flutes. Here I just finished parting it off on the lathe, just turning down the shank to 1/4 inch and parting it off, obviously. As you can see, it turned out pretty well, got pretty good finishes on most of it. So now all that needs to happen is cutting the square. Here you can see I just used a collet block on my manual mill to cut the square. It was just easier than putting it back into the CNC mill. Little stainless steel sleeve, threw a little rag in there so it burns off the oxygen as it warms up. Now I just got to seal at the top. So got the folds done, hammer them tight to keep them sealed, double folds there so that it seals the best it can. A little bit of paper in there so when it burns off only extra oxygen. So go into this little oven. I put them up on these little pieces so that it gets a little more airflow around it. Warms up a little quicker that way, or at least more evenly is the hope. And let's see whether I remember how to set this. I just power cycle it because then it goes back to the main menu. Kind of a weird fluke. Okay, 15 minutes. Up to 1400, hold it 20, hold for 20. 1700, hold for 20. pulled these two and it runs. Once the part was at final temperature, I took it out, cut it out of the stainless steel foil, and let it cool at air temperature. Once it was all the way cooled down, I tempered it for an hour in a toaster oven. Okay, so I have finished most of the pen parts. Here you can see one of them. It's got this thread in there. There's a different one. So it's got the thread in there. Yeah, so those were all cut with this tab. A2 tool steel, hardened it. It turned out pretty well. I'm actually really happy how well this turned out. It's one of the only taps I've made that the square end and everything else survived through the hole I was tapping, and this is the only one I've needed to tap more than one hole with. So yeah, I'm really happy with it. I'm really enjoying using A2 tool steel over just like O1 or other high carbon steels I've used. The heat treating process is a little longer, though it's all hands off, you know, and just throw it in the oven for a little while. A little bit of polishing with a stone inside the these cuts to polish up the teeth, and then it cuts. I also sand back the cutting teeth a little bit just so there's less friction. If I was going to use this more, I might do that to all the teeth because they definitely rub a lot. But overall, worked pretty well, as you can see, both of these. And then here's one on the pencil, and it works. See? Now, there you go. You can see the one issue I have. The way that the eraser piece connects is with these two tabs. So here I should be able to pop it out easily. Take this out, clean it off a little bit. So it's got these two, let's see if we can get that focused, these two tabs, so they catch on this groove here, but the issue is on the original pencils they have this thread stop about a quarter turn before the end of the before this groove, but I can't do that because, you know, this isn't a bottoming tap, and that's just unreasonable to have a tap stop in one at like have only one thread that cuts the whole shape. So this groove is not a full loop. It's actually, there's a whole section about this section. Let's see if you can get that focused. That section to about here. So when this goes in here, it does a pretty good job. It stays in, except for if you hit the wrong place, it starts unthreading itself. I'm not 100% sure how to fix it. This is kind of a unforeseen issue, but it does work pretty well. You just have to pull slightly in this direction as you spin it, which isn't really a problem, and it still works just fine. You know, otherwise erasing, adjusting it just a little bit. Like, you're not really going the full length unless you're just sitting there messing around with it. But really, if you're just adjusting it, it's fine. It looks pretty cool with the this is the original clip, and I just turned a slight little groove in there. Here you can see this part. This part works well too. Both these parts are fully functional. I just wanted the second one because my father wants one for his pencil, basically, and I have the lathe set up, so it's a lot easier to run multiple. Here's the first one that worked. I didn't have the groove programmed in because I thought I was going to do it a different way, but that turned out not working. I wanted to have it where it wasn't fully around the part, where it had this stop, so that the clip wouldn't rotate. Here you can see. This is the way this would be the best way to do it so it doesn't rotate, but it actually, the friction's high enough, it doesn't matter. This is a 3D printed kind of test part to make sure my model worked, and it is fully functional actually, which is kind of cool. Yeah, hope you guys enjoyed, and I'll see you guys next time.